Space Nuts.
And hello to our patrons, the people that put a couple of bucks in our tin can every month to say thank you for producing the Space Nuts podcast and to enable us to keep producing the Space Nuts podcast. It's not cheap. Everything costs money, and once you start to sort of build numbers with these sorts of things, there's all of a sudden these people coming out of the woodwork saying, "Oh, we can help you." Well, yeah, and that costs money, and some of them do. We've found some good collaborators to help us out with the Space Nuts podcast in recent times, and setting up shops and getting things produced for the shop, and it's never ending. But it's good fun too, though. And if you're a patron and you're putting some money into the tin to help us out, thank you so much. We do very much value your contribution. And if you would like to become a patron, you can go to our website and click on the support button and find out how to contribute. It is quite inexpensive, starts at about $4.50 a month, but you can contribute whatever you want. It's up to you. spacenutspodcast.com if you would like to look into that and check out the shop while you're there. Now, Fred, we are going to look at stars now. It's got nothing to do with Hollywood as usual, but they have pinpointed a bunch of stars, a couple of thousand of them, that may well, if they have livable planets orbiting them with intelligent life, they could go, hey, look at that. That's Earth. Oh, my gosh, we can see Earth. I'm pretty sure they wouldn't say it that way, but you get the drift.
They'd probably say it in a different language for a start.
Yeah, I'd say so.
Yes. Yeah, so this story, it's a quite a nice one. I think it's come actually out of Cornell University in Ithaca, New York, led by a young lady called Lisa Kaltenegger, and with other authors as well. What these scientists have done is ask the question, exactly what you've just asked: which stars could detect the planet Earth by the fact that from their vantage point, it transits across the disk of the sun. So, putting it a different way, what it means is how many stars are there that are exactly in line with the plane of the Earth's orbit? Because it's only if you're looking pretty well along the plane of the Earth's orbit that you would see the Earth pass in front of the disk of the sun. If you're slightly too high above or slightly too far below, you don't see it, which is actually, from our perspective here on Earth, that's one of the drawbacks of the transit method of discovering extrasolar planets. So it means you only discover a fraction of the extrasolar planets that are out there. But as you know, from Andrew, from our discussions, that's been by far the most productive way of discovering them. We now know of over 4,000 extrasolar planets, of which about 3/4 have been discovered by this transit method. And what that tells you is that planets are commonplace, that probably every star has planets. And that's big news.
Yep.
So turning it the other way around now, what are the vantage points from which any aliens who happen to have existed and avoided our detection systems with their UFOs? Oh, I didn't say that. What are the vantage points from which any aliens could actually see the Earth transiting? And what they've done is they've analysed star catalogues. And in fact, the best one now is produced by the Gaia spacecraft, European Space Agency's Gaia spacecraft, which has mapped 1 billion stars. It's an astonishing project, which we've talked about on a number of occasions, because not only is it able to map the positions of the stars with breathtaking accuracy, because you can do that, you can also detect the motion of the stars with similar accuracy, because you can look at a star twice and see how it's moved in between the two occasions. It's because of this stunning, resolution of the directions that stars are lying in to within microarc seconds is putting it technically, which is a tiny angle, and because you can measure them to that precision, then you only need to wait a few years, 2 or 3 years, before you can see them having moved, and that gives you the motion of that star through space. So what these scientists have done is taken all this information and not only said what stars are in the plane, lie in the plane of the Earth's orbit now and can see the Earth, or would be able to see the Earth transiting. What stars could do that within, have been able to do that within a period of 10,000 years, centered on now. So 5,000 years in the past, 5,000 years in the future, because the stars move, they cross the orbital plane of the Earth, extended way out into space, but they're only in it for a short time, and so that's why they had to look at this period of not human history, but the history of the Earth, 5,000 years in the past, 5,000 years in the future. And to cut to the chase, they discovered, now where did I put the final numbers? It's about 2,000, but they're broken down. So they've chosen ones that are within it's actually about 326 light years of the Earth. That is 100 parsecs, which is the measurement unit that astronomers usually use, a parsec, which is 3.26 light years. So within 100 parsecs of Earth, 326 light years, 2,043 have the quality that within that 10,000 years I mentioned, they have this perfect viewing geometry. They look in the plane of the Earth's orbit. Now, it's interesting that you can break it down into ones that are in the right location to have been able to see Earth in the past 5,000 years, and that turns out to be 1,715. And then there's another 319, which will come into view, or they'll be able to see the Earth transiting within the next 5,000 years. Of that 2,034 stars that would be able to see the Earth transiting, how many of them are known already to have planets? Well, the answer is 7. It's not many, but of course, many of them will also have worlds orbiting them, because we know that pretty well all stars have planets around them, and we will find some of them that are suitable for life. So it's really, it's turning the question the other way around. How many stars can see us? And what it suggests is, and the reason for doing this is that these are good places to look for alien, what you might call alien civilizations, but more especially to look for planets, to look for biomarkers on those planets, and perhaps technosignatures on the planets as well. So that is why this work has been done. It's to identify future targets for the big telescopes that are coming on stream, to really have a good look at these 2,000 stars, just to see if there's anybody there, because if there's anybody there, they will be able to see us.
Yes, that's right. It's a two-way street, isn't it? Really, if they've got the intelligence and the technology as we have, we could just look at each other and wave to each other like Marvin the Martian in Looney Tunes. He'd just put his telescope and it'd come right down onto Bugs Bunny's head. Right. But one of the candidates that's looking quite promising in the not too distant future is about 2050. This star will come into alignment. Teagarden star. And we'll be able to look at each other for 410 years.
Exactly.
Yes.
The one that I think is interesting, it's down the track. There is one of the most interesting systems of planets known to orbit other stars is the TRAPPIST-1.
I knew you were going to say that.
Which has 7 planets going around it, all Earth-sized. And we've talked about this system before because they have resonances with one another, these planets. One goes around twice in the orbital period of 3 orbital periods of the other one. They've got these resonances. But it can't see Earth at the moment, the TRAPPIST-1 system. But in a year 3,663, they'll be able to. So a couple of 1,600 years in the future, they'll be able to see the Earth. They will know that the Earth is there.
Yes, yes. Well, who knows what technology will be like then, and what we're capable of, and it would be a really fascinating time. I think we're in a fascinating time now, for good and bad reasons. But it's who knows what's around the corner? You just you never know what to expect when it comes to looking up into the ether and gathering it all in. It is truly fascinating. But yes, I suppose it'd be easy for people to find reports on these 2,000 stars and maybe have a look at them themselves and see if they can get away.
Yeah, exactly. It's easy to find the research that's been done there, and it's had quite a bit of publicity as well, which is nice.
Oh yeah. Everybody loves a story like this one. Okay, maybe more on that in the future, 1,000 years in some cases.
We'll let you know. Don't worry. We'll let you know.
Yeah, we will. Yeah, we'll get to that when the time comes. This is the Space Nuts podcast with Professor Fred Watson and Andrew Dunkley.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com. Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts.